Welcome to Lecture 19, Section 3.11. Alright, so we're looking at something that's called systems of linear equations, and we're solving these. So a system of linear equations, basically a system is a collection of equations, and we're talking about a specific type of equation. We're sticking with just the linear equations. And we're also looking at solving a linear equation system by graphing. There are other ways to solve, and we'll look at those in the next video. But for now, we're just going to focus on graphing, so solving by graphing. So when we are solving a linear system, we're trying to find where the two lines intersect. Alright? So in this case, we're talking about a linear system with just two equations, which is why we'd be looking at two lines. You can have more equations in a system, but we're just going to focus right now on the ones with two equations. Alright, so the place where they intersect is called the solution to the system. Okay, so what we're looking for is where the two lines would intersect. And there are three possible solutions to a linear system. And when you're solving a problem, you want to make sure to answer according to the type of solution that you have. So the first option we have, they intersect at one point. What would this look like on a graph? Well, if we have our little coordinate system here, y value, x value. So I'll just draw two random lines there, different ways that they can look, but here's an example probably. Okay, so there's one line, drawing in the next line. So remember, the solution is where they intersect. And where do they intersect? Well, it's right here at this point. Okay, so it's going to be some x value and some y value. Since they intersect at exactly one point, when you answer problems, you want to answer with that specific point. So we would write our answer as the point where they intersect. All right, so that's the first option. What do you think the other options are? You can pause the video and try to think about what you think the options might be. Alright, so another option, well, they can cross and intersect. Another option is they never intersect. How is that possible? Well, if two lines have the exact same slope, then each time you're moving up or to the right or the left, for example, rise or run, the other line is also moving up in the same direction. So if I was going from this point to this point, and I went up 1, and then right 1, this other line has the exact same slope, so it'd also be going up 1 over 1. They'd both be moving in a pattern that they would never actually meet each other. So now these, real quick, are going to be parallel lines. So they never intersect. They have so much in common, yet they'll never meet. Alright, so parallel lines, they never intersect. So that's one option. So is there a solution? Because remember, we're trying to figure out a solution to a problem. We're trying to look at where they intersect. And they never intersect. So do we have a solution? No. So you're going to answer that way. No solution. We're trying to see where they intersect, and they never do. Darn. Alright, so option 3. They are the same line. Okay, so the equation for them may end up looking different, but when you're solving, you might find out that they're actually the same line. Okay, so let's do, let's see. I'll go ahead and draw in this line. So that's my first line. And then the second line would actually be the exact same line. So to show that, I'll just extend off in this direction for the green line. So there are two lines, but they're actually the same line. So now what would my answer be for this system? Remember, we're trying to figure out where they intersect. Well, they intersect here, right? And how about there? How about over here? Or over here? or over here, and here, and here, and here, and here, they intersect so many times, it's not possible to count them. So what would we call that? How would we describe how they intersect? Well, the answer would be they intersect infinitely many times. All right, there you have it, the 3 different types of answers. First answer you have is when they intersect once, gives you a nice number, so you would just answer with that nice number, or sorry, that nice coordinate set, point. The other one is they never intersect, so you would answer no solution. Thirdly, they intersect everywhere because it's the same line, and that you would answer with infinitely many. Oh, it should be solutions, not times. Let me change that real quick. Infinitely many solutions. There we go. Alright, so let's keep moving on. So, when we're solving a system by graphing, this is the plan. First thing you want to do is you're going to graph the first line entirely. An easiest way to graph a line is to just find the x-intercept, the y-intercept, and then use your slope to find the third point. Because remember, when you're graphing a line, you always need to show 3 points. And that is something, again, that I will be checking on the exam notes, so make sure to include that third point, please. Alright, and the reason we graph the lines separately is because sometimes you can get confused if you're just plotting points. So always graph one line entirely by itself and then graph the next line. Once you've graphed the 2 lines, the last thing to do is figure out what kind of a solution you have. Is there one point of intersection? Are they the same line, so there's infinitely many solutions? Or do they never intersect, so there's no solution? Alright, so that's the plan. Now let's go ahead and get solving. Alright, so one thing to note, if on an exam it tells you how you need to solve something, you need to solve it in that way. So if it asks for you to solve the system using graphing, you would need to use a graphing method and none of the other methods. Because as mentioned, you'll be learning other methods in a video down the road. Alright, so enough of the spiel. Let's see. So the plan was, first is to graph one line. So I'll go ahead and pick this as my first line to graph. So first line, what do we need? Well, remember, we want the y-intercept, the x-intercept, and the slope. Alright, let's go ahead and do that. So how do we find the y-intercept? Well, my equation here, since it's already in slope-intercept form, we can just go ahead and pull the y-intercept off right here. It's the -3. Alright, which means my y-intercept is going to be 0, -3. That was not bad at all. Alright, so the x-intercept. Well, write down my equation again. For the x-intercept, we're going to set 0 for y and solve for x. So 0 equals -1/3 x minus 3. You can go ahead and pause the video and try to solve this by yourself. And then check back in with me. Add 3 to both sides. And then we get 3 equals -1/3 x. Alright, to get x by itself, I'm going to go ahead and do a sort of a double fancy move here. We're going to multiply both sides by -3/1. I multiplied by 2 negatives to get the positive. And then I multiplied by their reciprocal so that the 3's would cancel each other out. And x would be left by itself. But remember, whatever you do to one side, you need to do to the other side as well. And I'll add this over 1 on that side to make things a little simpler. Alright, so then I have -3/1 times 3/1 equals x. Multiplying that out, I get -9 equals x. And remember, once again, you need to write your intercepts out as an ordered pair. And Lastly, our slope. So since it's already in y-intercept form, as mentioned before, I can just pull the slope right off of the equation, which would be negative 1/3. And why do we need the slope again? We'll use the slope to find our third point for graphing. Okay, so as mentioned before, we want to go ahead and graph this one first. I will go ahead and graph this in blue. So we can remember first line, we chose blue. Alright, so let's see. 0, -3. 0, 1, 2, 3. I'll go ahead and write that in 0, -3. X-intercept, -9, 0. Alright, so that's going to be right here. -9, 0. And now we need to find the third point. Well, both of these points would be a good point to start with. I guess I'll just start with the x. Okay, so let's go ahead and use the slope to find our next point. So the slope says, and we have to choose to assign the negative to either the 1 or the 3. I'm going to go ahead and keep it with the 1. Either way will work, and you can go ahead and play with that and see that it will work. So -1/3, which means we're going to go down 1 and right 3. So here we go. Let me change colors, actually. Down 1 and right 3. 1, 2, 3. And there we have our third point. Let me go ahead and write in the coordinate point, which is going to be -6, -1. Please make sure to always label your points. Last thing to do is to draw these in. And you know what? I'm just going to follow the pattern and make it easier for myself. Alright, let's see how this goes. Oh, didn't look that great. That looks okay. The arrowheads look really bad, though. Let me change those arrowheads. Alright, so remember, arrowheads are important. Please remember to show those on your graph. And alright, there we go, the first line. So go ahead, pause the video, and try and find the information needed for the second line. So let me go ahead and copy down the second line. X minus 2y equals 1. Alright. Second line. Let me just make sure I copied that down right. Yes, I did. Awesome. Okay. Okay, once again, finding the y-intercept, x-intercept, and the slope. And since I have more room on this side, I'll go ahead and write the slope over here. Well, to find the y-intercept, two ways. I could just plug 0 in for x and solve, or I could get this in slope-intercept form and pull the y-intercept off of there. But I'll go ahead and make x 0 and solve it that way. So make x 0, and what do we get? We get -2y equals 1. Solving for x, divide both sides by -2 to get x by itself. And I have y equals -1/2. And there we go. My y-intercept, 0, -1/2. X-intercept. Well, remember, always just use your equation. And the plan with x-intercepts is always, you make the y 0. Okay, plugging 0 in for y. What do we get? We get x minus 2 times 0 equals 1. Well, anything times 0 goes to 0. So we get x equals 1. So our y-intercept, 1, 0. And lastly, our slope. How are we going to find our slope? Well, this is my equation. And let's get it into slope-intercept form, and then we can pull the slope off. So that means we need to solve for y. Let's minus x from both sides. And the reason I put the x in the front is because that's the normal form for slope-intercept form. Alright, last thing, divide by -2. Okay, let's clean this up a little bit and see what we have. We have y equals, and we have the double negative there, so it's going to be positive, minus a half. And the slope is whatever's next to x when it's in this form, which is going to be right there, my lovely half. And there we go. We have all the information we need for the second line. Let's go ahead and graph this. And I'll graph this in, let's do red. Why not? Okay, make sure to label the points. So 0, half. 0, negative half. That's going to be this one right here. And the other point is 1, 0. So 1, 0. Ooh, those are really close together, aren't they? And then our slope is a half. Okay, so I need to find my third point. A few ways I could do this. I could use the slope and count Razaran as up 1 over 2. Or, and I'm going to play around with the slope here. If I did that, I'd start heading in this direction, which is great, but remember, I want to figure out if they intersect. And it's looking like they should be intersecting somewhere over here. So to do that, I want to go back. Well, I'm going to be sort of sneaky here and play around with the half. I'm going to make this a negative over a negative. Can I do that? Yes, I can. Because what is a negative divided by negative? It's a positive half. So I haven't changed my answer. All I've done is made it look different. So now that I've added those negatives, my directions change a little. My directions are saying, go down 1, back 2. So let's go ahead and do that. I could start at either the x-intercept or the y-intercept. I think I'm going to start at the x-intercept because the y-intercept has a half and I don't like fiddling around with those values. So let's go ahead and count this out. Down 1 over 2, 1, 2. So that's 1 point there. Now I'm going to keep going until I actually find the actual intersection point. Down 1 over 2. Alright, so it looks like they intersect somewhere around here. And now, what you might be noticing is, we can't perfectly tell where they intersect. It doesn't look perfect there. And that's why, in reality, the graphing method is not the best method, which is why we'll show you other methods later. So what I'm going to do to make sure I actually pick the right point is I'm going to actually count out the slope of the blue line. So remember, the slope of the blue line was down 1 over 3. So I'll go ahead and do that from this point. Down 1 over 3. 1, 2, 3. Okay, they do meet up. Look at that. The red and the blue meet up. My line was a little crooked. So this spot here is where they intersect. Let me go ahead and first draw in my red line with my arrowheads. And there we go. Question, are we done? So close. Remember, step 3, we need to actually identify what kind of a solution we have. So let's see, what is our solution going to be? Well, they intersect at 1 point. But if they intersect at 1 point, remember, you need to tell me what that point is. So what is this point? Well, it's 1, 2, 3. So negative 3 for the x value. And then the y value is down 2, so negative 2. So the solution for our system is negative 3, negative 2, because that is where our two lines intersect. Now the hard thing is if your lines intersected at a place that was not perfectly at whole numbers. For example, if it intersected at a half point, a third point, or a fourth point. That starts to get hard to count off of a graph, which is why we're going to look at other methods down the road. But that is it for this section.